Okay, for today we started with practicing polar problems, which is basically like a little quiz that we are going to use to get ready for the test. The test is not going to be in our next class session. We have one more session of review, and then we will have the test on Tuesday of next week. All right, so what did you get for this first one, ED? What do you say?
4,
Negative 7 pi over 6, and that one was just 4 pi over 6 was there. We're just coming at it with the angle that goes like this. Okay, and then give me another one. You got it. So if you had been over here, you can then zip this way by making it negative. All right, how about the next one? Okay, and double checking that one. Oh, it's the same as that last one. You were just getting here using a negative angle, and then the negative makes you pop over to where the red point is. I like it. And then the last one. Oh, interesting. I didn't intend for it to be rectangular. So how about this? And I get it. I never wasn't clear on that. So who has a fourth way that involves polar? Yes, in the back. EE.
I did
4 comma 17 pi over 6. And you did that by basically adding 2 pi, which would be 12 pi over 6 to the original. And that is correct. Good job. All right, now let's do rectangular on this one. So if I draw it out, it went this way, negative root 3. And if this went this way, 1. And this last one is 2, because you should know this one. 1, 2 square root of 3. And then, oh my gosh, it's the same exact place. 5 pi over 6. But it's a different r. So it's 2 comma 5 pi over 6. Raise your hand if you had that one right. Okay, excellent. Let's go on to number 3. Tell me a strategy, Wilson. How did you attack number 3?
Make the 2 equations equal each other.
So, yeah, he said make the 2 equations equal each other. Another way to say that is if r equals 5, you can just put a 5 right there. And 5 equals, and then I subtract 7 from both sides. And then I have negative 2 equals negative 2 cosine theta. And then I divide by negative 2, and I get 1 equals cosine theta. Or the way I like to write it, cosine theta is equal to 1. And then I just think about what cosine looks like as a graph. And then I think, oh yeah, right there, right at the very beginning. That's when cosine is equal to 1. And that would be at 0. Another way to picture it would be to make your circle trig deal and say cosine of what angle would give me 1? Well, I want x to be 1 then. And this is the spot where it's 1, and that's 0. So either way, the answer is 0. But if you actually put just 0, you will get it marked wrong. Why, Wilson?
You need to include the r equals 5, so you need to make them intersect, so it would be 5 comma 0.
A point of intersection has to be a point with an r comma a theta, and the theta is 0, but the r was given back in the original problem, and it was 5. You are correct. 5 comma 0. Okay, number 4. It's converting. Henry Jones, tell me what you would have done first, because I bet you didn't just like directly swap these out. Did you multiply everything by something, or did you square it, or what did you do?
I multiplied both sides by r.
I like it. That's what I would have done. And that way, r cosine theta, we know that one. That's x. R sine theta, we know that one. That's y. R squared, we know that one. X squared plus y squared. Now, is this easy to solve for x or y? It says solve for r or y if it's easy. Well, that's not going to be easy. Okay? To solve this thing for x or for y would be pretty gross. So you don't have to solve it for x or for y.
Can you just subtract one of them over?
Nope, it's not that simple. Let's imagine that you did get them together. You got both x squareds together, and it was like x squared minus x, and it wouldn't be equal to anything. You know, it'd be equal to variables, and then you'd have to. I'm not sure. I think I could figure it out, but it would be pretty gross. All right, moving on to the next one. This was actually a typo. What do you think I meant to put right there? y over x, and then you could have replaced it with tangent. But you're smart enough to hopefully know that if it's flipped, then it would be what? Cotangent of theta minus 1 equals, do we have something for x? Owen? R cosine theta plus 7. How do I know that I'm done, Mr. Sinekin? All right, and I don't see any x's and y's, so I know I've got to convert it over. And all I see is r's and thetas. You don't have to have like cosine in it even. If it just says r equals 7, that's clean, and that would only be in polar. It doesn't have to have thetas. But it just, if it's polar, it can't have any x's or y's. All right, how about this? Did you catch this one? Theta is something you're supposed to know. Inverse tan of y over x. And then equals is equals, of course. And then pi over 6, how do you convert that? And then there was so much quiet in the room. Yes? I'm not saying you're wrong, but I'm saying, would that really have changed it from like polar into rectangular? So it's a trick question. You don't need to change it. Just like if I had the number 7 in there, would I need to change it into rectangular? The number 7? No. If I have the angle 30 degrees, would I need to change it into polar? 30 degrees is 30 degrees. Pi over 6 is pi over 6. It's the same in both languages. So pi over 6, done. Doesn't need to be changed. That goes back to the definition of like, when do you know you're done? There's only x's and y's. What's that though? Isn't pi just a number? Remember, pi's just a number. So when it says pi over 6, that means 3.14 over 6. Yes. Yeah, because you're supposed to know that this is actually just a number. If it had said 3 over 6, would you have changed it? You know what I mean? If it had been 3/6, you would have said, well, that's just a number, Mr. Server. We don't have to change that. And pi over 6 is just a number. Yes?
For the previous one, if you did on like the test say r cosine theta over r sine theta, would that be wrong?
Nope, that would not be wrong. If cotangent had been replaced with something it's equal to, I'd have been okay with that. All right, one more thought. It says solve for r if it's easy. Now, for most of you, you'd be like, well, that's a judgment call, and I would say it's not easy. But you could solve for this r because there's only one of them. It wouldn't have been that hard to solve for this r. I'm going to show you how you could have, because that's something you may have to be able to do. Cotangent theta minus 8 is equal to r cosine theta. And then is r alone yet? Nope. Divide both sides by cosine theta. You can divide these separately by cosine theta? Or you could have just said all divided by cosine theta over there. Like this could have been just one big denominator of cosine theta. Because they have a common denominator, right? So you could put them together, couldn't you? All right. Is that solved for r? Yes, it is. And that's the one that I was thinking would be pretty easy to solve for just r. Because there's only one r. All right. Now the last one. The last melon. Remember, there's more review coming on Monday. Let's get through this last one. Dylan, would you give me what you had for 0? Raise your hand if you agree with Dylan and you think it's 3. You are correct. Bilderbeek, what do you say about pi over 6? All right, I will accept 2.7, but I know some of you notice in the directions use exact answers, which means you probably should have left that square root of 3 in it. Or square root of 2. So what was it if you left a square root of 2 or a square root of 3 in it? What'd you get? Square root of 3 plus 1. And I'm happy, though, that you knew that that was 1.7 and therefore made it into 2.7. It's just understand that's an estimate. It's not exact. This one's exact. Wilson, what'd you get for pi over 2?
I got 1.
Excellent. 5 pi over 6. McLaren.
I didn't have an exact answer, but
It's okay. That is an exact answer. I think you're confusing that with a decimal answer. Oh, I see. But you've converted it for me. I appreciate that. Next one, pi. Kyle, could you possibly shut that door for us? It's got it kind of loud out there. Pi. Sam Larson, what'd you get for pi? All right, I'm going to walk you through it. So we have a pi right here. We got to do cosine of pi. Hint, here's where pi is, right here. So that spot is at -1, 0. With that little guidance, can you tell me what cosine of pi is? Cosine is the x of it. All right, there you go. So that's a -1. So now we're going to put that in, and we got to do 2 times -1, which is -2, plus 1. Who had -1 for your answer? All right, awesome. And last but not least, Kavanaugh, the 3 pi over 2. Raise your hand if you had 1 for that last one. Okay. Now, when we graph these things, they don't look very nice. Like, they don't tell you, gee, this is where my circle is. Okay. But let me show you what it generally ends up as. It kind of looks like that. Now, how could you have known that? Well, you wouldn't, because on a test, you'd have to graph a lot of dots. If you graphed enough dots, though, just think about it. If you have enough dots, and it's going like this, it'll be pretty obvious where it is. But we didn't have enough dots for that. We only had 6. Okay, so how are you supposed to know that on the test? I would say we would expect you to know what it looked like if it was a circle, or if it was one of these kind, and I called them if a circle and a heart had a baby. Circle heart babies. Like this. It's got kind of a dent in it. All right, that's just kind of a ballpark idea of what they look like. So how are you going to know if you're right? Well, if you're not sure, if you're like, some parts are obvious, like I'm making dots and I'm going around a circle and I can tell pretty obviously that there's a circle happening here, but you're not sure in a certain area, like I kind of have this big void here. Well, then find a few points in that area. And if you end up with getting your final points in it, you're like, oh, I see where the dent in this thing is. You'll be able to tell. And if you need more points, make more points. How? Pick angles. Stick them in the formula. You can make as many points as you need to. Okay, so how many of you would have had, if these were each worth 1 point, how many of you would have had a perfect paper? Just curious. All right, there's only one of those. How about 1 or 2 wrong? You'd have been that category. That's almost everybody. Awesome. Now, if yours was like a train wreck, well, then you should study more this weekend, because the average kid in here is at 1 or 2 wrong on this type of a quiz. Okay, and we have one more day to study. That's almost exactly where we'd want you to be. I'd be a little nervous too if the test was on Monday, but with an extra review day on Monday and the test on Tuesday, I think you're going to be fine. So what should you do this weekend? I strongly recommend that you go and do some of the problems in the notes, because there's notes and then there's review problems in the notes. Because your assignment for the next day is going to be to do the rest of them. So get some done early. And don't leave like a 3-day gap in your learning. Otherwise, you're going to forget a bunch of stuff right before we review and test. Okay? All right, so there's the plan. And that's all I have for you for today.